All right, so today we are looking at writing the equation of a piecewise function. So we have been graphing them. Now it's our turn to go the other way. So it's up to us to figure out what this equation looks like. So the easiest place to start, in my opinion, is to figure out where the split is happening. Right?
-2.
Yes. So what I'm going to have is you kind of work backwards here. So I'm going to figure out, here's one equation, which is going to happen only if x is less than -2. So that first, sorry, let me get this in the screen. There we go. This left-hand equation is only happening when x is less than -2, right? And then I'm going to figure out what this equation is down here. And that's only going to happen if x is greater than or equal to -2, right? It's the or equal to because that one's filled in. So now all I have to do is figure out what the equation of those two lines is. This one I know right away. What's the equation of this one?
-2.
-2, right? It's just y equals -2. So this one I literally just put a -2 right there. This one's a little bit trickier, but it's not that bad. So I have to do y equals mx plus b. I know what the slope is, right? You can tell what the slope is just by looking from one point to the other. The slope is, well, it's 1, right? So I'm going to put in 1 for the slope. And now, since it is just 1, couldn't I just follow it and see where it would hit the y-intercept? So I can see what my y-intercept would be, even though it's not quite there yet. So if I just extend the line, I know it would hit right here, and that is 1, 2, 3, 4, 5, positive 5. So that means this equation is just going to be x plus 5.
Oh.
Does that make sense? Now, sometimes it's not that easy. Sometimes I can't tell what the y-intercept is, or maybe the y-intercept isn't at a nice point. Don't forget, you guys know how to write the equation of a line if you have not just the slope and the y-intercept. You could have just one point and the slope. You could write it in point slope form, right? And then you can always rewrite it into y plus mx plus b if you had to. You can even do it if all you have is 2 points. You would just have to find the slope and go through the motions, but it's definitely possible. So if you can't just figure out what the slope and the y-intercept is, you can always do it that way. Does that make sense so far? All right, let's take a look at the second one. So the second one's going to have 2 splits. So let's start. So I'm going to have really 3 things that I need to figure out. So I'll figure out what those equations are in a second, but let's figure out like where our breakdown is. So this top graph, this one, usually we go left to right on the graph. There's not really a set order. It's just sort of, that's usually standard what we do. So we're going to start with this leftmost branch. Where does that one exist? Yeah, if x, by the way, if you leave out the word if, it's not that big of a deal. But there's usually a comma after whatever your equation is, and then there's the region that that graph exists in. So this one exists when x is less than -2. Where does the middle one live? So this middle function, where am I going to say it lives over here? And yeah.
Less than.
Yeah, so if this is, I'm trying to do one of those and sandwiches. So I want to write this as a compound function. So I want to start with my smaller number, -2, which x is going to be greater than or equal to, right? The x is greater than or equal to the -2. And then on this side, I want it to be less than 2. So take a moment and look at that. See how my arrows, they're always going to point this way. You're always going to have your smaller number here and your bigger number here. And then it's just a matter of if it has the bar underneath it or not, whether the dot is filled in or not. Is that all right? Everybody sees that? Okay, those are a little bit weird to get used to, but once you get the hang of it, no big deal. And then go ahead, figure out where the last one lives. Careful. So where's this last one live? Yes, x is greater than or equal to +3. So far, so good? All right, now that we have that part established, now we're just going to go back and figure out the equation of each of these. All right, so let's start with the first one. So start by figuring out the slope. So remember, in order to figure out the slope, you want to find two perfect points. So here's one right here. And then the next one looks like it's my open circle. So if I'm counting the slope from this point to this point, what is that? Say it again. 5/3, right? I'm going up 5/3. So there's my slope of that one. And oh man, this one's not going to cross nice, is it? That's okay. So they don't always, right? No, it wouldn't. My next nice point's going to be like there. All right, so let's figure this out. I know the slope, 5/3, and I have a point. So I just need to write my equation in point slope form. And then we'll rewrite it in slope intercept. You ready? So do you remember how to do that? So I'll just go down here. So point slope form, remember, was this one. Y minus y1 equals m times x minus x1. We have a point. You could do -5, -3. Or I know this one doesn't exist, but that is like if my line kept going, my line goes through that point. The function just doesn't exist right there. Do you get what I'm saying? Like, I know it's not part of this function, but this line exists at -2, +2. You get what I'm saying? So if you want to use -2, +2 as your point, you could. If you would rather use -5, -3 as your point, you could. You just need a point on the line. I'm going to use -2, 2 because it's just nicer numbers. So I have -2, 2, and the slope we already determined was what, 5/3? So now we just plug in all the pieces. Remember, that's x1 and that's y1. So when I plug it in, y minus 2 equals my slope is 5/3. X minus -2 now turned into a +2. All right, so now all I have to do is get this into slope intercept form. Not too bad. Let's just distribute that 5/3. And then I'm going to add the 2 to the other side. But instead of adding 2, couldn't I add it as 6/3 to make my denominators match? Right, and then the same thing. So now I'm here. 5/3 x plus, I get 16/3. Did you? Is that all right? So now I know what goes in the top spot. 5/3 x plus 16/3. The middle one, luckily, is easy. What's that? 4. And then the bottom one, this one's not too bad, I don't think. So what's the slope of that one? -2. So let's see if I can just sort of trace my way back to find out what the y-intercept is, or if I'm going to have to up 2, back 1. It would be 1 above this. So where am I? 1, 2, 3, 4, 5, 6, 7. I get it at 7. Do you guys agree? It would be at 7. So now I can put that all together. My slope is a -2 x plus 7. Oh, sorry. I didn't realize I was off the grid. But there you go. Yeah, so I just traced it back. I'm going, if I continue this line, I know I'm a little bit off the grid, but I know I'm only one space up, so I can just count up 7. How's that? Are these okay? Now, the third one, something weird's happening. Or maybe not so weird, I don't know. we've seen a couple of these where two of them like sort of meet at the same point, right? And then it kind of looks like they connect just sort of like in this broken way. So I'm still having a change happening at 0, aren't I? That's where the change is happening between my two lines. So when I go to write this one, all right, I'm gonna have two branches of this one. Something's gonna happen there, something's gonna happen there. So this one happens when? Okay, let's talk about, okay. Where does the other one happen? And then I'll go back. So here's the thing, right? How do you know which one of them is closed and which one of them is open? You actually don't know. You have no idea which one's closed and which one's open, but you can't have them both closed. Because if you put or equal to down here also, if I said, hey, find me f of 0, which one would you plug it into? It would fit into two spots, wouldn't it? And that's a problem. So you can't ever have a number that can fit into more than one branch. So how do you know who's going to be the or equal to and who's not? It actually doesn't matter. You get to pick. You just have to make one of them open and one of them closed. Don't make them both open because then the graph would literally have an open circle there. Does that make sense? So you could have put that bar down here instead, but it's got to be somewhere because I need somewhere for 0 to go. But I can't have 0 going to two places. Has it? Does it not matter if what? You're going to get the same value. Yeah, because they meet there. It wouldn't matter if you plugged in 0 to the top or the bottom. You should get the same value for each, but I can't have, I'm not allowed to plug a number in and have it be able to go to two branches, even though they're going to give me the same answer. But if I make them both with the or equal to, then I wouldn't know which one to go to. Does that make sense? But you're right. You're going to get the same answer either way. So that's why it doesn't matter. You pick. Do you want it on the top or on the bottom? Up to you. Okay. So now let's just figure out the branches. So this one, what's this equation? This one's not bad. Yeah, it's just x, right? It has a slope of +1 and it's hitting at the origin. So that's just the slope of 1 crosses at 0. So I can literally just write x. And what is this one? Doesn't look too bad either. 2x. Also crosses at the origin, has that slope of +2. How do we feel about this? Are they all right? Not too bad, right? Okay. Yeah, so 4 has some weirdness going on. So maybe try it. See what you think you're supposed to do with that. I'll give you a hint. There are 4.
Yeah, that's right.
Yeah, you're gonna have 4 thingies here. Yep.
They're both going. They're both going. I think it is possible this is greater than the next. I don't think I don't know.
You're thinking of, here's where x is 3, right? This line is where, so this is where x is greater than 3 on that side. So it means you're just gonna graph the line on that side. This is where x is less than -3. This part over here only refers to those walls, those vertical lines. So this means that this graph is only graphed on this portion of the coordinate line. This means that this line is only graphed on this portion of the coordinate.
Oh,
Yeah. Okay, yeah, that one's okay. That one's okay. All right. So let's talk about where everything is, or are you still working? I'll give you another minute. Okay, so let's talk about our breaks. So this one happens, what am I gonna say for the, where this one is graphed? When X is what? Less than -2, right? So I'm looking, here's a wall right here. This one is only graphed when X is less than -2. Then you've got this middle one that exists where? So this middle piece, here's a wall, here's another wall. Where does this one live? Jimmy, go ahead.
-2 less than or equal to X, which is
Perfect. That's it. Oh, sorry, you can't even see it. Sorry. There we go. Yes, that one only lives in that little region. So pay attention here. We have a closed dot there. So that should be, have the bar underneath it. And then an open dot right there. Okay. Next one I'm going to talk about is this dot. Where does the dot live? At 1. So yeah, I'm literally just going to write X equals 1. And then I'm going to talk about this last piece, which exists where? Oh, I missed something here. I thought that this was an arrow that kept going, but it's not, right? This one actually stops here. So this one's going to be another one of those compound inequalities, right? Because it doesn't just keep going. Because at first I was just going to say, oh, X is greater than 0 or greater than 1. But that's not quite true, is it? See how it stops? There's a definite endpoint right there. So what should I be putting here? Yes, like that. Does that make sense? Because it only, again, it's one of those ones that only exists in that window. It's not going to keep going forever because there's no arrow on that side. All right, now it's up to us to figure out the equations. This one looks like it has a slope of what? -2. And so I can figure out where it would hit the y-axis. Oh, -4, right? So that's easy enough. -2x and a -4. This middle flat line, where's that? 3. And this dot, I mean, isn't it at 1, right? So I have y equals 1 if x is equal to 1. So I just get this one little dot. And how about this last one? What's this? Ooh. Oh no, okay. What's the slope of this thing? -1/2. And now let's see if we can figure out that y-intercept. So unfortunately, it would go up 1, back 2. But if it does that, I do actually kind of know exactly where it's going to hit. Doesn't it have to be a 3.5? Right? If that's my slope. So I could go through the motions of doing point slope form, but if it's a half, it's got to be a 3.5. So plus 3.5. I'll do 3.5. Also, when you finish, especially if it's a test or a quiz, you know I'm going to tell you to check yourself. So you can do the same thing. You can just pick a point and say, okay, when F is, what's a good one to choose? 3. When I plug in 3, according to my graph, I should be getting out 2. So I might just look at mine and say, okay, if I'm going to plug in 3, oh, it would fit into here. So let me see, if I plug in 3, that's a negative 1.5, negative 1.5 plus 3.5 is 2, right? Oh, good. That matches what I was supposed to have. So if you really want to make sure that you have this super right, you could plug in a point on each sort of section and just double check yourself. Okay, according to the graph, when I plug in -4, I should be getting out +4. So let me see, if I plug it into the function that I created, when I plug in -4, I sure hope I'm getting out a +4. So let me see, oh, -4 would fit here. So that would be 8 minus 4 is +4. Yes. So I'm fairly confident, but again, you'd have to check for each branch, right? Because just because you got one branch right doesn't mean you got another one right. But anyway, doesn't take very long. How do we feel about that one? Goodish? Now, what does number 5 look like to you? Oh, yes, I was going for absolute value. You're not wrong, though. It does look like a check mark. So here's what's so interesting. Absolute value graphs and equations, you could rewrite them as a piecewise function. And that was the next little tidbit that I was hoping to get to today. So instead of having it written as our normal absolute value that we were graphing the other day, you could have this as as a piecewise, right? Isn't it a function that's getting broken? And I'm kind of following 2 different paths. So let's give it a shot. Now, whoops, f of x equals thingy.
That's why I need a good review before that.
Well, luckily, you don't actually need to remember the absolute value part for this. You need to know the piecewise function part. So go ahead and figure out where this thing splits. Okay, did you get your equations? Where do they split? At -3. Now, there's this overlap. So again, you're going to pick one of them to be open and one of them to be closed. It really doesn't matter which one. One's going to exist when it's less than -3. I'll make this one greater than or equal to -3. So either one is fine. You would just have the bar on one of them. Okay. Now we just need the equations. Looks like the slope of this one is a -1. So I know I'm almost out of room, but I'm not that far off. I think it's -7.
Yeah.
So that one would just be a -x minus 7. And then the other one's super easy. That one's just what? X minus 1. Was that so bad? No. Should we try a few more of the absolute value ones? I thought you'd never ask. So while I'm handing out the next sheet, try 6 and 7 real quick. Yes, Jimmy. Why not? Just make sure you put from the water.
Oh, yeah, that'd be disgusting.
Okay, sure.
Thank you.
Well, how are you doing with all of this? Okay-ish? Okay, so let's take a look at your answer for number 6 real quick. Where does this first graph live? If X is what? Someone's saying it. It sounded right.
Greater than or equal to 1. Oh, no,
Other way.
less.
Yeah, we can put the or equal to there. And then this middle piece, where does that live? In between what and what?
1 and 2.
1 and 2. So since I already, if you put the bar there, you're not going to put it here. You can put it on this one if you want. So just make sure when I go to plug in 1, I don't want 1 to fit into both of these branches, right? So if you left that, if you didn't put the bar there, then you would have to have it here. Does that make sense? You don't, and you want to make sure that someone has to have the bar. Otherwise, 1 would have nowhere to go. And then the same thing happens over here. Since I already put the bar there, I'm not going to put it there. So I just do a quick check and I say to myself, okay, if I'm going to plug in 1, does it only fit into one of these branches? Yep, it would only fit into the top. If I'm going to plug in 2, does that only fit into one of these? Yeah, it would only fit in here. I just don't want any of my numbers to have 2 different locations to go to. All right, so that part's done. Now we do the equations. Top one's nice and easy. What's that? What's this one right here? X plus 3. Slope of 1 crosses at the y-intercept, or at 3. So this one, ooh, 1, 2, 3, 4, 5, 6. Looks like we have a -6 slope. And although it's off my graph, I can figure it out, right? If I'm here and I have to go up 6 and back 1, I'm already at 4. So where am I going to hit? Nick? 10, right? Wouldn't I have to cross at 10? Because I know I'm going to go up 6, back 1. I'm already at 4. So if I go up 6 more, I'm at 10. So that one's going to hit at 10. And then this one's not bad. That one has a slope of 1, right? Where would that one cross the y-axis?
4. Just kidding. Oh, the y? Oh. Just, yeah, negative.
-4, yeah. Right? Because if I just kept this going, ding, 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 I'd hit right there at -4. And there we have it. Okay, so there's that one. And then 7. Kind of fun to draw those curly brackets, even when you mess up. Look, it kind of looks like a face. Right? You see like an eyeball and like here's the nose. Maybe these are the lips and it's got a big chin. I don't know. Anyway. Yeah. He's like a Gaston. Doesn't he have a big chin, right? All right, anywho. Oh, yeah.
Good job, Jill. Okay, sounds good.
Okay, so I'm gonna, where is this top branch gonna live? This one right here. I'd say top because it's top over here. This leftmost branch, I mean. If X is what? Less than -1. It's an open dot, so I gotta make sure that that one's less than. The middle piece lives where? Where's that middle piece live? Yes. Now listen, this one, but Mississippi, I thought -1 had to have a place to go. No, not this time, because there literally is no value at -1. So I don't want -1 to have anywhere to go. It doesn't exist there. So I can't plug -1 into this function because there's no answer. So that's why it doesn't fit in the top and it's not going to fit in here. So if I were to ask you what the value of this function is at -1, what would your answer be?
No solution.
No solution or undefined. You can't, you're not going to tell me +1 because that's not true. It's an open circle there, which means it doesn't exist. There's literally a hole. All right, and then this one's just gonna exist if X is, so here I already had the or equal to bar there. So I'm just gonna do that. So I don't want +1 to fit into 2 branches. Does that make sense? Okay, and now let's just get our equations. Luckily, this one looks pretty good. Anybody have this one here? What's that?
2x plus 3.
2x plus 3, I agree. Slope is 2. If I kept that line going, it would hit at 3. Where's the middle one? 1. And then this one, oh, another nice one. Where's that? Just x, right? Is that what hit at the origin? Is that so bad? Nah. Okay, so I just gave you a new sheet that says absolute value practice turning into piecewise. So let's look at the directions here. The directions say 1, graph each equation, and then 2, rewrite the function as a piecewise equation. So let's refresh our memory on how to graph these when they're written as an absolute value. So if you recall, this was the general formula. A times x minus h plus k. Remember that? And then the point h comma k is our vertex. And then what was the deal with this a? What is that thing? That's the slope of the right-hand branch. Okay, so for number 1, where would the vertex of this thing be? Nate? 4, 2. So remember, we're always taking the opposite of the number that you see right there, but leaving that one as it is. So the vertex of this thing, let's see, I'll stick it right here, I guess. Vertex, so of this is at 4, 2. So I'm going to start my graph at 4, 2, and then where does it go? What's my slope of that right-hand branch? Just a 1, right? If there's no number in front, it's just a 1. So from here on the right-hand side, I'm going to go up 1 over 1. And then remember to do the left-hand side, I just mirror it over. So there is the graph. And now part 2 says rewrite that as a piecewise function. So that's exactly what we were just doing. So now I'm going to look at my graph. I'm going to kind of ignore this because I don't even care what the equation was. And I'm just going to look at this and I'm going to say, okay, well, where is everything splitting? So as a piecewise. I'm going to have 2 pieces, right? Oh, I did leave myself a ton of room. So it looks like everything is splitting at 4. So I'm gonna have one of them be, oops. One of them is going to exist when x is less than 4. And then my other one will exist when x is greater than or equal to 4. Doesn't matter who has the or equal to bar. And now I just need the equation for each separate line. So the first one, what's that? Who can give me the equation of this top one? This one right here. Adam? Yep. Negative x plus 6. I've got that slope of -1 and it's starting at a +6. And then this piece, if I were to follow it back, it's going to hit at -2, isn't it? What's the slope of this thing? +1, right? Aren't I just going up 1 over 1? So that one's going to have a slope of +1. And where did I say it hit? I already forgot. -2. And there is the same thing, but written as a piecewise function. So how cool is this? On your quiz, I could ask you to graph that, or I could ask you to graph that, and you would produce the exact same graph. Weird, right? Because they look very different from each other. Let's do one more together. Let's see, do I have really hard ones? Let's do one of the ones on the back that has a different slope. How about 8? That one looks all right. Okay, so step 1 is to graph this thing. Where's the vertex of this? So if I'm graphing it like a normal absolute value, where is this thing? Where's that vertex? 4, -1 is correct. So we're going to start at 4, -1. And then what do I do? Why, yes, I do follow the slope as indicated by letter A, which is this right here, whatever is in front of my absolute value. So that's the slope of my right-hand branch is 2. So from the dot that I just made of the vertex, I'm going to go up 2 over 1, up 2 over 1. And then to get the left, I just do it in reverse. Okay, remember all absolute values are going to end up being a V shape. So if your graph is not coming out as a V shape, something's wrong. What's that?
That's -4.
Yeah, I think it should be +4.
Oh, yeah, I wrote it right and then I put it in the wrong spot. Sorry. Good catch. +4, -1, silly goose. There we go. Thank you. And then we're going to go up 2 over 1, up 2 over 1, and then reverse for the other side. So sorry. There we go. Okay, so there is our absolute value graphed. Now it's our job to rewrite it as a piecewise function. Give it a shot. Think of where is this thing splitting and then what's the equation of each branch. When I'm like thinking about making the curly bracket, I can't do it. I think it gets all messed up. That is not Buzz Lightyear. I don't know what that is.
That was Sam.
What?
You always think it's me. I literally said it wrong. That's not, was it really me?
Yeah.
No, it was not.
All right, this thing breaks at +4, right? So make one of them a less than and make one of them have the or equal to part, okay? So I'm gonna split it up as such. Again, that bar underneath could be there, but it's gotta be on one of them. All right, this branch right here, what's the equation of this one?
-2x plus 5.
Not +5,
Plus 7.
+7, yeah. And then my other one, slope of 2x, you'll notice that your slopes should always be the same, just one's positive, one's negative, right? Because they're those mirror images of each other. But where is that y-intercept? Let's see. Oh, I'm gonna run out. Down 2/1. -9? Yeah. I can always double check myself, by the way. If I'm like, oh, is it, am I too far off? This is what I think it is, according to my graph. So for example, when I plug in 5, I should get out 1. So if I quickly plug in 5, yep, I got out a 1. So if I was off by 1 right here and I had it at like -8 by accident, it wouldn't work out. And I'd be like, oh, that wasn't right. So I could fix it. Okay, so how do we feel about this? You could do it?
Yeah.
So let's talk homework.
Let's do the whole back.
I think that's reasonable.
The whole back.
Yeah. So, yeah, and then it's just the one side. So could you please finish the back for homework? That's 7 through 12. I will put this on Jupyter in just a moment. Okay, so that's gonna be number 7 through 12.